Hello and welcome to our What's New session with SAP Datasphere. My name is Klaus-Peter Sauer, and together with my colleagues on the product management team, we will be updating you on the latest features and functions we delivered in Q4 2025. So looking at the agenda, we will be covering updates with new features and enhancements in the data integration, the data modeling, and also the administration area. At the end, I will give you an outlook on what we plan to deliver in Q1 2026 and the next couple of quarters. So let's get started with the new features in the data integration area with Nikhil, Hannes, and Sai Krishna. Over to you guys.
So we have added this new banner when data flows are being created, which is we're trying to nudge customers to use replication flow and transformation flow, and this will probably create some awareness and also increase the usage of rep flow and transformation flow going forward. As we see in some of the metrics in the back end that customers are still continuing to use data flows, we are still trying to dig out and understand why is that. But at least for now, we are trying to create more awareness because uh, replication flow does offer bigger connectivity, delta load support, and it's more resilient and scalable compared to data flow. And also, we'll have the difference between data flow and replication flow published in our SAP portal as well to provide that context as well to the end users. And we will also see this banner for certain data flows when they edit those data flows, and we'll see that banner uh, so as to create more awareness. Uh, this doesn't mean that we are going to provide any migration tool at the moment, but we are trying to see what we can offer to the end customer so that they can offload from data flow to replication flow and transformation flow.
The first user story is a long promised one and finally coming. That means we can now load from HANA spaces into object store spaces by sharing a HANA table over to a object store space and then be able to consume this in transformation flows. What this enables us is basically bringing HANA data over to the object store world. So we can reuse data that resides already in HANA. We can tier data. That means we can offload data from HANA into Datasphere. Also, we can use it for migration of data from HANA side to the embedded object store side. And with that, we also can use connections. We can also share some remote tables over. And it would allow us also to implement combinations, right, where we're writing data into HANA first because it might be quicker especially for small or real-time data updates, but then store the long-term, long-tail data, large data sets inside of the object store. So you're fairly free. I think it's a powerful and flexible to use way to design your use cases for this. How does that look like if we are in a object store space and I can search for a local table that I have, and let's take sales orders. We can now share this to the object stores. Prior, you would not see object store, so I'm sharing it over to the object store space now. I'm not going to do this, so I can do it again in a demo. I have already done this with sales order items, and you see they get similarly to normal HANA sharing, they get the space sharing items. Now, if we switch over to the object store space, we will see this previously sales order items shared data again with the receiving share symbol on our side. And so you actually see this comes now from my HANA space. And with that, this table becomes usable inside of this space. So I can use it in transformation flows as a source and just drag and drop it in order to write it. But also I can not only use it on the top canvas, I can also remove this. And if I go, for example, in a view, if I want a more graphical view, I can use this as a source for my graphical view. And with that, you can then apply your regular filters or any kind of other functionality you want to use. And then basically the output gets written into the target table. So I get my HANA sales order through a view target, and if I want to, I can add Pythons or do other things that I can normally do in the object space, store space, and then I can also take over the structure by simply saying that, okay, I want to create a new target table, and it will take this one over from the source. So here, this now basically allows us the connectivity between the HANA world and the object store world, so that you can use sharing. What is not covered by this is the ability to share between two object store spaces. That will come a little later. We are working on that already.
With this user story, we have extended the aggregation feature in Spark transformation flows in the Delta mode, because we had aggregation prior only in full mode, and some waves back we delivered the first set of aggregations to the Spark transformation flows in Delta mode, and now we extended the type of aggregations that you can do by average, max, and min, because those are a little bit more complex aggregations that we need to do, where we need to sometimes even look in the historic value in case of updates. One of the biggest ways of understanding is if you're having a max aggregation, for example, and you have an existing value that is max, and now you're updating this value to a lower value. That in result means you need to figure out, okay, what was the second biggest one, which is now the new biggest one. And therefore, it was a little bit more of a complex task to enable this in the Spark logic. So we have now built this to give you a little bit more option, and it's available now. How is that done? So let's have a little look in the system, and I have a simple transformation flow that takes the sales orders, puts it in a view and writes it into a target. And let's remove a column, for example, that we want to use for aggregation by putting in a projection. Maybe I remove the items from my sales order, and I want to exclude this and bring them across. And now let me remove my target because I have create a new one. So I create a new target with one less field. So now basically, if I would load this in Delta, I would have to aggregate. And I can now basically formulate how I can aggregate. The change is very small. So I have now here the min, max, and average ability basically to say, okay, give me the averaged net amount and the average tax amount per sales order item in a sales order by leaving the sales order clean. So I can add the min, max, and average aggregation in these dropdowns. Sometimes you see only min and max. And why is that? In this case, we're coming from an integer and we are writing into an integer. And if you're writing into an integer, obviously there's a problem. We can't store the average. We can store min and max. That is still there. But if I have a value of two values that need to be aggregated, the one has a value of 1 and the other one has a value of 2, the result would be 1.5, which obviously does not fit into an integer. So if you want to average integers, we need to cast them into decimals first so that we have a place to store the decimal data as well. So yeah, this is why here on the target side, as it's an integer, we can't store the average result into it. That's why we hide the average. But other than that, it works basically the exact same way as it does for the other aggregations which we already had in the system. So by defining this, you're getting now 3 more aggregation types. And that's what this story will deliver. With this user story, we have delivered a feature to create Delta tables that are not Delta enabled. So you have the ability to turn the Delta capture off, which wasn't possible before. And that means we're not going to have those two CDC columns of the opcode and the change timestamp. This is basically in order to allow full load transformation flows from HANA tables which do not have the Delta table or the Delta feature enabled. And it will also act as a source or a prerequisite for a future user story where the replication flow will then allow to replicate non-Delta sources into the object store with this feature off. It's basically something we had in HANA for a long time. Actually started out with HANA having it always with off, and then there we introduced the Delta table on. Now in the object store we started the other way around, having everything in Delta and now having the ability to turn it off. And with that also losing the ability to load in Delta with transformation flow out of those tables. How does that look like in the system? So if I am in an object store space and create a table, we still have as default the Delta enablement on, and you see that it has actually already added 2 columns in here, but now I have the ability to turn it off. And then those columns are gone and I can just define my tables as R, and you also see that the Delta object is no longer showing here. So that's basically the way how I can create now tables without Delta capture turned on inside of object stores. So a very small story, but kind of like a prerequisite for some of the other stories that we have and that will come in the future. This user story brings us the cancel merge task feature. That's a gap closure that we had previously. You were not able to cancel running merge task in case you should to or they ran too long. So now we introduce this little cancel button in the local table files data integration monitor, so that you have now the ability to trigger the cancellation of a running merge task. How does that look like? So if we are in the data integration monitor and are in local tables, and you see here I have a table that has data in the inbound buffer, so unmerged records, I can go in and I can now start the merge, and I will choose a big one so that it takes a little while to start. I can start it and see it starts running. Now, while it's running, I can go into the task details and have the cancel button, which I can hit. And what it will do, it will create a second job that cancels the start job I started, like we're doing it in all other type of cancellation roles that we have. So we should see here now the merge I just triggered and the cancellation as well, and they are completed. So I see the cancellation code. The idea here behind here is just to keep a full record of who has done what, so I know in both cases it was me by manual execution that I canceled the task. So this way you have now the ability to cancel running merge files, and it basically behaves similarly to all other cancellations that we do, where we also always create this cancel task. And that's it for this little user story. Thank you very much.
This is a small feature related to replication flows in a Datasphere. So we are scaling out this RWMS to maximum of 16 worker graphs. Previously, if you see existing systems, which has a maximum of 10, we can't increase it with existing setup. And this configuration is per tenant. So now with this wave 24, we increase this 10 worker graphs to 16 worker graphs. How we can adjust this thing? Using a data integration data blocks. Here we can see the screenshot. Here we can adjust this change from a 10 to 16. So what is the business value for this change? Especially replication flows customers with 16 worker graphs. Now customers can load a large amount of data for their initial loads using a replication flows.
So let's move to the modeling and consumption area. I have one feature here. It's about the custom choropleth layer support in SAC for geospatial analysis of Datasphere data. So choropleth, it comes from Greek. Choros is area and or region, and plethos is a multitude. So quite often, many of us end up pronouncing this as choropleth instead of choropleth. So you have to excuse me if I do that as well during this presentation. So what does a choropleth map do? It brings together 2 data sets, spatial data that's representing a partition of geography space into distinct areas called districts, and statistical data representing a variable aggregated within each district. The district is a generic term here, not the districts that we think about. So a district could mean any kind of region, it could mean a country, it could mean a county, etc. Right? So this is how eventually the representation looks like, and you can probably see that there are different shades. It doesn't have to be always the different color shades right now. It could be different shades of gray as well, right? In map-based visualizations on SAP, choropleth is the second most widely used geomap type. Was there a question? Okay. And now customers can enable own layers with custom shapes and organize them in a custom shape hierarchy as well. And these can also be combined with default shapes provided by SAP. And these shapes are enabled by following a set of steps in HANA Explorer. We have to connect to the HANA DB Explorer using OpenSQL schema and follow these steps. These shapes are also valid for analysis of geospatial data in any space of the tenant. That means that the same shapes will be used by all the SAC stories, regardless of where the analytic model resides. It could reside in my space, and somebody else who's a user on the same tenant could also use it. I've put the links and to the help doc here as well in the prerequisite and links area. Let's go to a demo now. So this is how the HANA-DB Explorer looks like. In order to display visualizations of geographical data, we need custom choropleth layers. This means we have to import what are called shape files. Tenants provisioned until 2025-23 provide default choropleth shapefile data. If your tenant's provisioned after that, you need to install it. So you can see here that you first need to create a database user and open its OpenSQL schema in HANA Database Explorer. And let's just walk through this quickly. I have done the preparation and I'll show you that in a bit. You have to go to the Software Center and look for DSP Spatial, and it'll pull up this zip file. You have to download and open that zip file. And once you create an open schema in one of your spaces, you can open the HANA Database Explorer, and you have to first start with the create statement SQL. This is what the create statement SQL looks like. So you'll have to execute this, and there's also another SQL file in that zip. It's called expose content.sql. You'll have to modify the grant statement here to refer to your relevant space and the user that you have created. This is the create statement SQL. I've executed this in preparation for this demo. The SQL statement creates these 6 tables, and you want to import the data from the CSVs into these files, right? You could just do that on the HANA Database Explorer. Then edit the contents of the expose content SQL and execute that. So you can see here that I have done that. This makes it available to all the spaces in Datasphere. Once the sharing step is complete, you have now installed the default choropleth data. Now let's see how to install the custom choropleth content. Let's look at this example. So here we import the regions of boundaries in England. So what is the example that we are considering? We are looking at this regions boundaries data set, and you can see here that this is published by the Office of National Statistics, and this is what happens. You can hover over all of these regions. These are the custom shapes that we have in the UK, and these are all depicted by an object ID. You could have a look at this data table, which corresponds to different regions for each value of the object ID from Northeast in England to the southwest of England. So you can see here that this is referencing the SRID 27700. So you go to HANA DB Explorer and import the data, and specifically there's an option to import ESRI shapefiles, and that takes a while. So I've already prepared that. Now, this is the generic statement, and this is a specific one specific to this region. You can see here that I've executed this as well. And once you do that, you want to add your custom choropleth layers to a hierarchy. And this is what the various parameters stand for. And you want to basically execute these statements. So once you've executed, you can select the custom choropleth layers in SAP Analytics Cloud. So before we go to Analytics Cloud, let me show you the tables that are here on HANA Database Explorer. And you can see that we created these 6 tables first, and then lastly, we created this particular table, and we have defined the hierarchy as well. We're using a dataset called NUTS, nomenclature of territorial units for statistics. I have a dimension that I've defined called NUTS dimension. And you can see here that the semantic usage is dimension, and you can see the data preview. The reason I'm showing you this is to show you how to define the geocoordinates column. Define a calculated column here, and this option should show up as soon as you define this view as a dimension. This is the location I've defined as a calculated column. And here I have chosen the latitude and longitude as those respective columns from the original table here. Let me now show you the analytic model that we are using. I've used the soil erosion as a fact, and we have associated that with the dimension that we just saw. And let me quickly take you to a preview here. I could choose the latitude, longitude, and the location. Hop over to SAC to see the geospatial data with the custom choropleth layers. As an analyst, I have logged into SAP Analytics Cloud. Now I need to add a geomap widget to the story. Now I need to add the layers. I come here, I want to add choropleth, and the layer style is shapefile. Let me call the layer name as observed value, right? I need to choose a source. So I'll come to Datasphere, go to my space, and I'm choosing the analytic model for soil erosion. Zoom this over to the Europe region. I have to choose the location dimension. Let me save the story. So let me define the hierarchy, select the custom hierarchy here. Let me add the choropleth color measure, the observed value here. And look at that, you immediately got the values highlighted using our custom region in the hierarchy, right? So it's now specific to the English regions, and you can hover over and find out what the observed values of soil erosion are in the different regions, as we looked at in the table, right? You could also change the color palette here if you prefer. something like this, this. So that's how you could use the data that is built in Datasphere in SAC. And as I mentioned in the demo, the new Datasphere tenants that are provisioned are done so without any geomaps, and users need to download these default shapes from the software center and follow the procedure. What's the business value? So we do get rich geo-based analysis with custom shapes in with a custom hierarchy as well. And these custom shapes also help in territorial shapes. So for example, there might be some regions which have territorial disputes. So each of them could use custom shapes to display the relevant map borders according to those regions or nation states, right? So this feature deals with what happens when the properties of entities that are part of an analytic model change. We all know that an analytic model depends on source objects like dimensions, views, and facts. When the properties of such source objects change, its impact gets reflected on the analytic model status. The business value here is very relevant to data modelers. Such changes to the underlying entities of an analytic model are handled gracefully in this case, and this helps them react very quickly so that models can take action to fix errors and redeploy the model. So what happens here is as soon as one or more changes are detected, the editor generates a warning so that the changes that are made are displayed to the user that they're affecting any directly dependent object. So if you have a fact that is directly being used in an analytic model, then you have that warning saying that such and such analytic model is affected. So what happens here? The status of the analytic model changes to deploy, which means that some changes just need a new deployment so that the analytic model can read the latest metadata by adjusting its runtime artifacts. Or in the other case, when there's a design time error, this is apparently unrecoverable since the analytic model is broken through such a change or such changes, and which means that the analytic model should be fixed and we need to redeploy that. It's worth noting that the updates will cascade to also the stacked analytic models. So most of you must be familiar with stacking of analytic models, which we recently introduced in Datasphere. And if such a case happens, what you could do is fix the base analytic model and redeploy. As long as you have not made changes to the stacked analytic models, the redeployment of the base analytic model will fix all of those analytic models in the stack. So this is how it looks like. So you can see that at the top right that there are about 3 validation warnings. And if you dig deeper into one of those warnings, you will see that it's telling you that the attribute fact attribute has been changed. It may affect the dependent objects. In this case, the dependent object is an analytic model. So let's quickly go to a demo. I'll start with the stacked analytic model. Let me show you the lineage here. So I have the stacked analytic model called AMStack1Calc. It's dependent on a base analytic model called AM calculations, which is dependent on a fact called opportunity items. This is the base analytic model. You can notice here that it has a couple of measures and a number of dimensions. The state that we start with is that both of these analytic models are deployed. Now let's go to the fact. You can see here that this is a fact table. I will go to the attributes and measures, and I can make any number of changes. So if I want to change the aggregation here, notice here that my validation count went up by 1. Pay attention to this count. Let me undo this, and you've started with 0. I can change the semantic type, let's say of product ID to text. The count has gone up. I can change a text association. I can change one of the associations and remove that, you can see here that the validation warnings have gone up to 3. If I drill down to any of these validations, it tells me that this particular attribute has been changed and the dependent object is an analytic model that will be affected. Now let me undo these changes. So I make a couple of these changes and then save this here. And when I refresh this page, I can see that both the base model and the stacked analytic model have changed their status to changes to deploy. Let me deploy one of them. And now you notice that only that particular model changed to deployed and the other stacked analytic model stays on changes to deploy. So we just saw that changes to the properties of an analytic model can result in one of those states. So the state that we saw was changes to deploy, and we would now like to see what happens when does it go into design time error. And this table that I have shared here is an exhaustive list of changes that actually we could come back to and refer to, so that I have included it in the slide so that you guys can use it. It it's a very exhaustive list. As you can see, you can make changes to facts, dimensions, and in the analytic models to measures, variables, input parameters, and the like, right? So now let's go to another demo and look at what happens and how do we get the design time error. Now let's look at another scenario. I will go to the associations and remove one of the associations here. I get a validation warning that the association has been changed and may break dependent object, again pointing to our analytic model. Let me go ahead and save this. When I refresh this page, I will get design time error on the base analytic model as well as the stacked analytic model. So this is how you can see that any changes to the source objects of an analytic model immediately propagates to the analytic model as well as the stacked ones, helping the modeler take action to fix these errors and redeploy the model.
Hello, this is Finja, and I would like to show you our new OData feature for analytical OData APIs, where you can select only dimensions. The use case here that it is for front-end development, meaning that when you, for instance, create a value help dialog and you would like to see the distinct values of a dimension or of a combination of dimensions, that you can only choose those dimensions in the selection and don't need to select a measure just to have a measure, and that is then aggregated. So what you can then do is, when you have only dimensions that you want to select, you select which columns you want to have, and then select a list of those columns. A brief demonstration is when you have your analytic model and you go up here to your OData service, you can then, with the select parameter, select which columns you would like to see. And if I choose, for instance, the sales order ID, then I can go to the preview, and now it shows me only the values that are in the sales order ID column. And it doesn't show me all of them for the sales order items, which would mean repetitive values, but only the distinct values that are in the sales order ID column. And that's it. Thank you very much.
Okay, then I will take it forward. I have a couple of topics that I want to talk about. The first one on my list is the cancel, start, and stop operation support for an Elastic Compute Node. So before I start talking about the feature itself, I'll give a little bit of background. Uh, the Elastic Compute Node start and start process, it entails that an Elastic Compute Node is provisioned in the first place, replication is performed, and then the routing to the Elastic Compute Nodes is then performed, which means that from that point onwards, after the routing is done, all new queries for that space coming from SAP Analytics Cloud would be routed to the Elastic Compute Node. So these are the steps, as you would also see in the screenshot here, that it somehow shows, I'll show in the system as well. The idea previously was that whenever a customer started an ECN or stopped the running ECN, they would have to wait till the entire ECN start or stop process has completed for them to roll back. And it happened that in some cases, customers by mistake either started ECN or started an ECN that was not running anymore, and it meant that they have to wait for the entire provisioning process, followed by the replication process, followed by the routing process, for them to actually roll it back, and then take a similar amount of time to roll back the entire change. What happened as a result was, in some cases, the status of the ECN was not rightly maintained. As such, there were problems with the states of the ECN, but more importantly, there is metering that happens as soon as an Elastic Compute Node is either started or as soon as it is deprovisioned. And customers, they face the brunt of it because they clicked the start button by mistake, not knowing that there might be another step in between, or whether there is a confirmation that is required. But then the metering already began, and they started losing their credits as soon as the Elastic Compute Node was started. And then the replication took, maybe in some cases, few minutes, but in some cases, in some extreme cases, also a couple of an hour or so, where the replication was stuck. And as such, customers had to pay the metering price as well for the time when ECN was running. There was a request from customers, and because of that, this feature is now has been introduced, that whenever there's a start or a stop process that is activated for an Elastic Compute Node, it's also possible to cancel that process. Now, there are a few things that one needs to consider. That the provisioning and the deprovisioning process is something where HANA Cloud is involved, and the replication and the routing process is where Datasphere is involved. So whenever you have cancelled a start process, meaning that you have started the process to provision ECNs, and if you cancel that process, then there are a few intricacies that are involved, and I'll talk about it when I go into the system. The idea is to support rollback whenever possible and bring the system to the original state in as many cases as possible. I'll now show it in the system. But before that, I would very quickly want to also show a little bit of the help portal, because it also talks about exactly this. So the help portal now has a cancel the start or stop process as a separate section in the documentation, and this documentation actually talks about the way that the statuses are set and the way that different processes are triggered because of a cancel action on a start or a stop process. Okay, so in preparation, because ECNs take a lot of time to also get provisioned, and as such, we require some time to test the behavior. I'm going to quickly show you only the initial part and give you an idea of how it is supposed to behave. So I have this ECN which is currently in a ready state, so it has not been started, and I click on start button now, which means that now I have asked the system to start the ECN. And let's assume that I have made a mistake and I want to cancel this now. I can go to logs, and here I see already that it tells me that the process is running, right? If I go into this process, it tells me that it has started to it has started to provision the ECM, and then it is at the moment running. We'll wait a few seconds here. As soon as this add Elastic Compute Node process starts, so you see that these are the different states that I was talking about. The first one, where you are adding an ECN, then this is the point where you are replicating all the data into the ECN, and finally you are routing newer queries into the ECN coming from SAP Analytics Cloud. So now this add ECN process is running. Now we have a cancel button here that I can use, and I can cancel this process. What is it going to do is that it is going to create a new cancel task chain. In this case, you see that this previous one was run chain technical, was the actual one that we had triggered because of the start process. But now it has a cancel technical chain that is actually directed towards the original task chain. So now this task chain is going to cancel. The only action for this task chain is to make sure that this run is cancelled. Now, if I go here in a few seconds, the status of this would also be changed, and it will reflect something like this. So I'll just show you a previous one for the sake of saving time. See here that it says that it says that it has set the status to failed, even though the at ECN status was set to completed, because I started a task chain and I immediately decided to cancel it. Maybe after the ECN was added, right? And this is the entire idea, that at any point in time in the entire process, one should be able to cancel and revert back the system to its original state from where it had all begun. Right? I'm still trying to check whether it has cancelled, but no, it's taking a little bit longer. But the idea would then be that this is also set to this overall task chain is also set to failed. Right now, if at all you cancel a task chain after the ECN has been provisioned, what it will do is that it will stop the rest of the replication and routing process, and also cancel this task chain, but you have to stop the ECN manually. Right? This is something that is also mentioned in the documentation, and this is an expected behavior because of the way that these different tasks are happening. The overall idea for us here is to ensure that you are able to cancel the process. I'll just go back and save some time, because there was another one that I was also setting up for exactly for these scenarios, so that I can show you the behavior. Give me a second. If I see the logs of this one, I was previously stopping this as well in a similar manner, and I just want to show you how it behaves. So in this case, there was a stop chain that was created because there were some replications that were already done. So what it does is that because I stopped a start process or I canceled the start process, it also then took care of dropping all the replicas and reverting back the state. The idea of showing you this behavior is to just entail that, or just allude that uh, the system tries to bring you back to its original state as much as possible. If at all it is not possible, then a manual action is required only for stopping an ECN that has already been started. Right? The overall goal is to save as much of administrative effort as possible, but wherever it is not possible to revert back, this is then documented as such. Because now you see here that it still tells me that the ECN is running and I can stop it, because the ECN provisioning process might have completed by the time the cancellation was done, and then I can come in manually and I can stop this process. That was the overall idea of showing this. The motivation being getting out of inconsistent states and avoiding additional metering that will be resulting because of an elastic compute start or stop. More information about this can be found in the documentation. The second item that I have now is on a different topic altogether, which is data access controls. And here we are talking about the support for user attributes. I would again like to give a little bit of background. Uh, Data access controls, they work in such manner that you have a data set and you want to protect this data set to ensure that only selected users can consume the data based on their permissions. Uh, so far, what was happening is that we always assigned permissions on a user level, meaning that if you have 100 users that need to have access to particular rows in your data set, you need to have permissions for all those 100 users. But this then becomes a big administrative task, because we can easily go from 100 users to 10,000 users to 100,000 users. And then it means that you also need to manage permissions for all those 10,000 or 100,000 users. And this has been a talking point with all the customers, the feedback that we receive, that we need to support scaling in this manner. And to support scaling and to ensure that there is some level or some kind of grouping, we have begun on a journey where we will introduce more and more ways of grouping users. The first one that we are trying to now bring, and this is one of the biggest capabilities that have been added to data access controls in quite some time, is the support for user attributes. Now, we have user profiles that are coming from an identity provider in Datasphere. These user profiles on a regular basis bring in information like what is the email address, what is the name, what is the city, all those information along with what are the different custom attributes that this user profile has, so that you can map it to different roles. So in a way, the IDP is going to bring you all the information into your Datasphere tenant. This will help you create that user profile, but at the same time, assign the right roles, right privileges to that user on a tenant level, or assign scoped roles in that manner as well. So this is how it's generally used. Now, we are now extending the support, and we are saying that from an IDP perspective, you'll not be able to just assign scoped roles or global roles, meaning access to tenant or access to spaces, but also dictate access to data within a space wherever this data is protected using user attributes. Now, on a user attribute level, apart from the normal user attributes that the user has, for example, as I said, name, city, company city, or cost center, you also have custom attributes that could be maintained. And there are 10 custom attributes that are maintained on an IDP level. But in general, 5 custom attributes are where these are mostly common with most IDP, most providers, whether it is a custom IDP or SAP IDP. And now we are leveraging these custom attributes that come in from the IDP directly in our data access control. So just imagine this flow where you create a user in the IDP, and that user has some profile information because of which they get access to a scoped role and then to a space or to the tenant. And now, because of the use of attributes, you can also already have access to the data within it. And I'll show you how, so that I can show you all the different combinations of how this is done. I'll go to the system directly. Let me first show you the documentation, because the documentation extensively talks about all the different custom attributes that are used. So we are able to use 5 custom application attributes from custom 1 to custom 5, but you could also use the other attributes that you have, the standard attributes, as I mentioned, city, company, cost center, etc. And then you can use them in a way that you can embed them in your permission entity. And now the point of permission entity is where we'll talk about how they are coming into the picture. So you see here that your permission entity for a boolean or an operator in value DSEs looks something like this. Just ignore the ID type for a moment, right? You have your permission ID, which is your primary key, but then you have your different IDs that you have. Initially, we had the email address, and then the restriction followed by criterion operator and first val, second val. But now we have an ID type, and this ID type is going to dictate where is the source of this information, or where is the source of this ID coming from. All your existing email addresses, the way that you assign your permissions today in data access controls, is then mapped to 0. So all that you do today, I mean, before this feature was released and feature was available, you are always mapping it to 0. But then you can also map it to custom attribute 1 to 5. And for that, you will use the ID type, and you will mention 1 to 5, similar to what has been mentioned here. Right? 0 is the standard user identifier, and 1 to 5 are the custom 1 and custom 1 to custom 5, respectively. Now, I know that this might seem a little bit too much at the moment, but just stay with me, because I will show you in the system as well. Just a second, let me get rid of all of this. I have an admin console here to show you how I've mapped my attributes. So in my demo profile, I have mapped my custom 3 attribute and my custom 4 attribute to my group 3 and my group 4. You can think of this as anything. Maybe this is the role of the user, maybe this is the location of the user, maybe this is the department of the user, or maybe it is just a user group that you are trying to virtually create. So let's say that my user is part of a user group, which is my group 3 and my group 4. Right? It could be for different reasons and it could be for used for a variety of reasons. Now, when you have your data access controls, and now I'm back in Datasphere. Here now you have a new checkbox that says allow IDP user attributes as identifiers. This was not present initially before the delivery of this feature, but now you have it. Once you turn it on, let's see. See here, you have a new configuration. Initially, it was only identifier column, but now it is the identifier type column. And you have to tell the system where exactly does your identifier type sit. So 0 to 5, the numbering 0 to 5, where does it sit? So for me, it sits in the column source ID. I'll show you the permission entity for sake of completeness. So you see here that at the moment I've just created a permission entity with for a dummy user. And now I have mentioned that there is my source ID, which I am going to use. If I show you the analytical model that is protected, obviously at the moment I should not have any access to any data whatsoever. Let's make sure that is the case. Perfect. So now you see that there is no data that is shown here because for my user in the permission entity there is no data that is uh, existing. Now I'll create a new permission and I'll say that my source ID is custom attribute 3 and my ID is going to be Waldorf because my user has a custom attribute city that is also used here, and my user also has a custom attribute my group 3 that is used here. So I'm going to say that anyone who has the ID Waldorf in their custom attribute 3 is part of a restriction group, and then they can see all the sales org with that are equal to America, right? Simple as that. I'm going to form a Boolean DSC. This, whatever I'm doing here, is not part of user attribute capabilities, but it is part of the Boolean DSC behavior. It is exactly like that, right? Now, if I go back to my analytical model and if I refresh it, I would expect to see uh, Americas here exactly, right? So you see that now I'm able to see because my user is part of a user group because of the user attribute that gives Waldorf. Now, what I'm going to do here is I'm going to add another permission and I'm going to say that the same attribute is also bringing me something like my group 3. If I have a my group 3 or whichever user has my group 3 in their uh, custom 3 attribute and the part of restriction, also show them EMEA, right? Now, if my user has this attribute, I should already be able to see it. You see here that I'm still talking to my demo user. Right? I'll go into my, uh, difficult to actually do all of that. Okay, maybe this works. Um, and then I add my sales org. And now you see that I all of a sudden now start seeing another sales org that we have, EMEA in this case. Now, just to make it a little bit interesting, I'm going to say that I have my original way of handling it. And if the user has the email address amokulkani312, then also show them all sales logs that are equal to APJ. Right? This is what I'm now telling the system. Because this is my user, I expect to see a new row in here that is now for APJ. Exactly. Right? Now I will mix it up a little bit. Now you see that there are a lot of partners in APJ. And I will take one of these partners. Okay. And then add it into the permission entity. Now I'm going to say that anyone who has my group 3 in the same restriction. Let me complete writing it, and then I will tell you what I'm exactly. Perfect. So what I'm telling the system is now I'm trying to group these two restrictions together. Again, this is a behavior of Boolean DSCs. This has nothing to do with user attributes. But what I'm telling the system is that I want to club these two together in an AND condition. All of these are OR conditions. Because of this, you saw that either the this condition or this condition or this condition is validated. But now I'm trying to club these two things together, and now I'm telling the system that if the user's email address is this, then show them everything for APJ. And if they are part of this group, only show them partners that have value less than this. Right? This is what I'm now telling the system. Now you should see that the number of partners that we see here will drastically reduce, or should drastically reduce, if I have maintained the right numbers. Sorry, this and this. And now you see that I'm only showing something that is less than 18 because I am part of a group. My user in itself is getting me all the information for APJ, but my group is giving me only a restricted access on these partners. Right? The idea of showing you this was that with the help of the IDP attributes now, you can maintain permission. So even if I get rid of my user per se, I can assign permissions to a user. So I'll refresh this for the sake of completeness again, because we are now at a stage where uh, you see this one is that it is showing me only selected partners, but it is also then showing me all of this information. If you look at the permission entity now, nowhere have I mentioned this user's email address, which was the case before the release of user attributes. The idea of releasing this feature now, or having this capability, is that it will be possible to assign permissions to users without having to directly grant them permissions on per email address. So from an IDP perspective, you need to add users to a group, and that group gets a permission instead of individual users getting permissions, right? This is just the first step in a bigger journey where we will have more and more ways of grouping. There is no UI that is required because everything is handled from an IDP perspective, which means that an administrator on the IDP level can handle who's part of which group, and the modeler can then maintain which group gets which permissions.
Thank you, Amok and colleagues. So let's move on to the outlook and what we have planned in Q1 2026 and beyond that. So looking at the first features we planned for Q1 2026 is about the task chain area, where we want to deliver a public API for triggering task chain runs from outside, and as well as at a later point in the quarter, we also want to deliver input and output parameters as part of task chains. Before that, we also plan to introduce success and error parts on the task chain side, and on the OpenSQL schema side, we plan to introduce certificate-based authentication. For replication flows, we want to introduce Oracle as a new source capability, as well as support for the cloud connector for cloud data and cloud object stores in Q1. And also on the replication flow side, we want to support Parquet as a format, an additional format on the supported targets side. On the input parameters side, we want to introduce that feature now also on ABAP for ABAP CDS views, as well as on the replication flow side, the possibility to maintaining the order of primary keys. This is sometimes important, that there's a correct order which can be influenced, which is now not the case at the moment. And on the transformation flow side, you also want to be able to transport the runtime configurations for transformation flows. On the modeling side, we want to introduce now the time period calculations like month to date, year to date, quarter to date in Q1, as well as the long-awaited sharing of analytic models, including all of the contributing entities like facts, dimension, hierarchies, and the likes to other spaces. And what we also want to introduce is the concept of display attributes in analytic models that you can select and define that there. Moreover, we want to introduce another AI featured functionality on AI-assisted SQL generation on the SQL View Builder using GenAI and Joule. On the semantic onboarding side, we want to enhance that feature also for calculation views coming from HANA Cloud, and metadata extraction for replication flows will be an enhancement for the catalog component. So looking further down into Q2 and later quarters in the year, we want to support also Microsoft SQL as a target in replication flows, as well as also a long-awaited REST API connectivity features support in replication flows. On the scheduling side, being able to schedule delta loads through task chains. Then on the modeling side, restricted measures in analytic models on hierarchy nodes, as well as multi-fact modeling, which we plan. On the catalog side, crawling for HANA Cloud artifacts, as well as S/4HANA and older ECC versions. And on the audit logging side, we want to introduce or add the integration of user and authorization management events also for audit log. That this is tracked later in the year. Then features like schedule handling upon user deletion, namespace introduction, sharing of dependent entities, and of course what we did throughout the quarters is expanding the data center coverage across Google Cloud Platform, Microsoft Azure, but as well also new data centers introduced on SAP infrastructure. So that's it from my side, and thanks a lot to all of my colleagues preparing the great content today, and I hope to see you around next time. So take care and see you soon. Bye bye. Thanks for being here with us today.